Good afternoon, everyone. My name is Chandra Balani. Welcome to this webinar on getting started with AWS. I'm the regional manager based out of Hyderabad, and I'm going to take you through in the next hour and a half on getting started with AWS. A brief introduction about me. I take care of the business development for a region, we call it EROI, which includes east of India, as well as AP Telangana, includes SAARC countries like Bangladesh, Nepal, Bhutan. Based out of Hyderabad, completed 5 years last week. So I'm in the beginning of my 6th year at Amazon. So welcome once again, and let's get started. So what are we going to cover today? We'll give a brief introduction of AWS. How did it start? Why customers choose AWS? Overview of some of the core services, how to get started, and then we'll also cover some of the case studies. All right. So with that, let's get started on the introduction part. When we were running as a retail company at Amazon.com, we were managing our infrastructure, in our data centers, as you would see. But .com was a growing business, really growing, really fast, and it needed huge amount of IT infrastructure, which we were managing internally. But as we were managing our data centers, we were coming across some of these, challenges. So we had to invest in large capital expenditures. We were running out of data center space very quickly. Was highly underutilized IT assets because we need to plan for peaks. A lot of time you over provision it, so that leads to underutilized IT assets. Scaling up was a challenge. Scaling up quickly, that is, scaling down was also a challenge, not possible rather. There were vendor lock-ins. Managing physical growth was a challenge. Pricing was getting too complex. Contract negotiation every time we need to buy assets was also getting very, very difficult. I'm sure some of you who are managing your infrastructure in your data centers would relate to some of these challenges that we were facing as we were growing, right? So that's when Andy Jassy, who's now the CEO of Amazon Web Services, was brought in by Jeff Bezos. He was Jeff's shadow at that point of time, and he was asked to find out why are we running, slow, right? What are the reasons why some of the group companies, some of the products releases that are running, are moving slow? And he went around and spoke to a lot of product managers, and one of the common theme that came in was that most of them are waiting for IT infrastructure, right? So that's when he reimagined the model, wherein we would procure everything centrally and then distribute internally to different divisions and groups as a web service, right? And that was around the 2003 2004 time frame, and we started doing this very, very effectively. And that's where the aha moment came, that if we are doing it internally so well, why can't we make it as a business model and make it available to other businesses as well, right? So that's when AWS was born, and with the mission of enabling businesses and developers to use web services to build scalable and sophisticated applications. And that's what people now call cloud. So we started with this mission to enable businesses and developers to use web services to build scalable and sophisticated applications. So that leads to a question of what is cloud computing and how should we start with this business model. And we thought, utility industry went through a similar change, and they went through a similar transformation, and we would like to bring in the benefits in the similar fashion of what utilities industry used in the past. right? So how do we compare against a utility? So if you think about it, early 1900s, when a factory or an industry had to start, they had to first build their own electric station to power that factory, right? And over a period of time, the electricity generation, instead of an upfront project which each company would do it individually, uh, electricity generation started being centrally produced, and then all the users can utilize it on demand wherever they need it. They pay as you go. That is, the months they need more, they utilize more, and they pay more for it. And other leaner months when they are using less, they pay less, right? It is available all the time, at least most of the time. And then it is uniform for all customers. It does not vary from one customer to the other, right? So these are the typical tenets, or a business model of a utility, if you think about it. And we created a business model in a similar fashion, wherein we use all these tenets for IT infrastructure, right? So IT infrastructure, similarly, in late 1900s and early 2000s, any company that had to start, they had to first set up their data center to get the IT infrastructure up and running, and then comes the rest of the business. So we thought, why can't we do the similar electricity approach, wherein we can, create this centralized infrastructure in the form of cloud, and then consumers can use it in an on-demand fashion whenever they need it. They pay as you go, as they needed more at any given point of time. They can utilize more and pay more. Other times they can use less and pay less. It is available all the time, and then it is uniform for all customers. It's some kind of a democratic model, if you call it, right? So that's a concept we started with, and all these services which are running in AWS cloud are available through APIs. So all of your compute, storage, network, CDN, databases, load balancer, all these services that are there, they are available for customers to utilize in a pay-as-you-go model, on-demand, uniform, and available all the time in a API model, right? So these are the 6 benefits for cloud computing that we call it, right? Whenever someone uses the word cloud, which is now being quite loosely used, but we say that if someone says cloud computing, these are the 6 benefits you should look at. One, for customers, there's no upfront investment that they need to put in to get started, right? Second, the cost keeps going down as they continue using for a long period of time, right? And how do we do that? So when we started on AWS, and as we started getting customers, we had to procure infrastructure, and instead of buying, let's say, 100 servers, we were buying 1,000 servers, thousands of servers. And as we started growing and we buying more, we started gaining those economies of scale benefits, right? With those benefits, there are 2 things you can do, most companies do, is that they increase their margins. But AWS being, Amazon company, the retail, DNA, we thought we will look to, scale this and make this as a volume business with low margins. So what did we do when we were able to reduce our costs? We dropped our prices and passed on that benefit back to all our customers. So whether the customers were new or old, all the customers got a reduced bill from the date and time we announced. So customers love that, right? Instead of, let's say, $5,000 last month bill, this month it is let's say $4,000. You would obviously be happy, and that led to more usage by these customers. That led to more customers coming onto the platform, and then we grew again, and we again gained the economies of scale benefits, and then we dropped our prices again, right? So that has been a cycle so far. It's a virtuous cycle, we call it flywheel. And in the last 12 years that we've been operational, we've dropped our prices 67 times from 2006 till now, right? So not only you have no capex involved, but the opex also keeps reducing, right? Third benefit is that you don't have to guess the capacity. I think this is one of the most important benefit when using cloud computing, right? In a traditional model, you have to think of a plan how much is the ROI for a given project. Based on that, predict an amount of IT infrastructure you need. You a lot of times you go and put some buffers, and because you're buying infrastructure, you keep peaks in mind, additional users in mind for the next 3 to 5 years, and then you buy servers. And typically, the demand in the initial sometime is much lesser, which ends up you wasting capacity. And if the business becomes successful, then you cross that limit, wherein your customers are not happy because IT infrastructure is not available at that point of time, uh, you know to add immediately, right? With cloud, that changes. You can get started with as low as you need today, and as your requirements keep increasing because of new business coming onto your platform or new users coming in, you can keep on adding capacity. Now, with this, one important piece is the hardware sizing that you have to do is correct. But not only that, also the software license that you end up procuring based on your course are also much lesser, right? And then the hardware support and the software support, which is a percentage of your money spent upfront, that also comes down drastically, right? Fourth benefit that you get is the agility and the speed of innovation, right? When in a traditional world, it usually takes 6 to 8 weeks and sometimes even more to buy and get the infrastructure. But after you received the racking, stacking, switching, by the time you're ready to execute your idea, it is months. On AWS, that changes. You need to get started now. You got an idea now that you want to get started. In a matter of few minutes, you can actually spin up your infrastructure and get started. That also breeds in a culture of innovation, because whatever ideas you get, you can get started. The other benefit with cloud is that there is no upfront investment, there's no contract or commitment either, right? So we don't ask customers to spend a minimum amount of monies on the platform. And so you can get started with what you need, and after a few days, after a few hours, after a few months, if you don't need it, you can switch it off, and you stop paying, right? So the collateral damage is very low. You can fail cheaper, right? And when you can get started immediately, when you can fail cheaper, the speed at which you innovate also goes faster, right? You can try out multiple experiments in parallel rather than serially, and then cost of failure is very low. Again, that leads to you reaching to that successful POC quickly, and then you can immediately scale that up. Fifth benefit of cloud computing is that it lets you remove the undifferentiated heavy lifting of managing a data center, right? As IT teams, you can focus on innovation for the company, on various applications that you want to bring in. Managing data center is not adding any value to your business. So if you're a media company, you focus on building great content. You're a pharma company, you focus on creating new drugs, and so on, right? So AWS takes care of that undifferentiated heavy lifting for you, and we believe that we can do a much better job at scale, right? Sixth benefit is that it lets you go global in a matter of a few minutes, right? Today, if you're operating in a business and you're looking to expand to another country, and if you are working on a data center, then you have to build your IT infrastructure from scratch in a different country. and can be very, very time consuming process. Here on AWS, we have 18 regions across the world, and you might be operating in one geography. Tomorrow you have to operate in a different geography. You can sitting here, you can deploy infrastructure in a matter of a few minutes. And not only that, you also have templates with which you can create your entire architecture in one geography, and then reproduce the template in a few clicks. In a matter of an hour or so, you can deploy your entire infrastructure in a different geography altogether, right? So these are the 6 benefits of cloud computing. If anyone uses the word cloud, you should look at these six benefits. And a lot of times, if you think about it, people use the word private cloud, people use the word private data center cloud, co-location data centers, and they call it cloud, but none of these 6 benefits apply to them if you think about it, right? In a private cloud, you have to have upfront investment. Your variable cost does not decrease. You have to guess the capacity. The speed is slow. You have to focus on this. And if you have to go global again, you have to get started, right? So don't let anyone use the word cloud very loosely with you. You should question them. Hey, am I getting all these 6 benefits or not? Right? So with that, why are customers choosing AWS? Right? So as I mentioned, we have a global infrastructure. We have 18 regions across the world where we have physical presence, as you can see, on multiple geographies in US East, US West, Canada, South America, Europe. We have 4 of them. Asia Pacific, we have 6 of them. China, 2 of them, and then 4 more announced for 2019. Now, regions serve 2 purposes. One, uh, it helps you in uh, getting governed by the local laws with data sovereignty issues, right? So, for example, in India, the region is Mumbai, right? The moment you choose Mumbai, uh, all the data that you put in Mumbai remains in the constraints of Mumbai. It does not go out of Mumbai, right? If you want to cross replicate across a region, you can do it, but by default, it remains within the country. So your data residency rules, it are taken care of with these regions. The second benefit is the latency, right? You can serve the customers nearest to their region. And if you are serving the Indian customers, you use the India region. But as an Indian company, if you're serving to, let's say, North American customers sitting in India, you can deploy your IT infrastructure in one of the US regions that is most suitable for you, right? So that's the physical place where our data centers are hosted, right? Beyond that, we have concept of availability zones within a given region, which I'll cover in my next slide. And then we have a series of edge locations, which are nothing but edge pops for some of our services, which are like CDN service or a DNS service, wherein we have a string of pops across the world where some of these services are used from. I'll come to it in a little more detail when we get into the CDN mode. So from region, let's move to availability zones, right? Now, think of an availability zone as a cluster of data center, right? So AWS, when we say region, it is not one data center. In fact, a cluster of data centers forms one availability zone, and another cluster of data centers form the second availability zone, right? Any AWS region starts with minimum 2 availability zones. A region will have minimum 2 availability zones, and these 2 are isolated for failure, right? These 2 availability zones are physically away from each other by miles. They have a separate ISP provider. They have a separate power provider. They are usually kept in a location that they are completely isolated even for natural disasters, right? Having done that, they are connected through a fast network between the two, right? So much so that the latency between the two does not increase beyond a single millisecond, right? Beyond single digit millisecond. So it should not go beyond 10 milliseconds, right? A lot of people ask, why don't you, so when you say Mumbai as a region, both availability zones are in Mumbai. Yes, of course, they are miles away from each other, separate physical location, but they have a fast network connected to each other, so that the latency between the two is sub 10 milliseconds. So a lot of people say, why don't you put one availability zone in Mumbai and another maybe in different city, let's say Chennai or Hyderabad or Delhi, right? The answer to that is that the moment we take it beyond few hundred kilometers, the latency increases, and that does not help. Then the architectures that you can utilize with a highly available infrastructure on AWS, you cannot utilize some of those, right? So you can deploy one single application with architecture components deployed across both availability zones. That's the benefit that comes on AWS with this architecture, which is quite unique, because when you run highly available applications, you can use things like Elastic Load Balancer and deploy one web server in one availability zone, another in one another availability zone, one app server here, another app server here, database master here, slave here, and create an architecture which is highly available across these availability zones, right? And the beauty is, you don't pay anything extra by deploying these kind of an architecture, whether you run two instances in one availability zone or one in one and the other in the other. The price does not change for you, right? So you get to design your application which are highly available across this availability zone architecture. All right, moving forward, second reason why people look at AWS is because of the platform breadth and depth, right? Whatever you run in your data center, there's hardly anything that you cannot run on AWS, and much more. There are many more services that are typically not possible to run in a data center model, or in a private cloud model. So we have this global infrastructure that I spoke about. We have the core services, which is compute, storage, database, networking, and CDN. We have security and compliance services, as well as management tools. So as we see, the world has been moving forward from physical data centers to virtualized machines. From virtualized, they move to cloud. On cloud, we see people moving into a container mode. And then now what we are seeing is the rise of serverless, right? Wherein customers don't have to manage the underlying compute on cloud as well, right? Which is where we have launched the service called Lambda. So Lambda is an event-driven compute that can run a function for you rather than you managing a server for yourself, right? So we have launched serverless for database as well. We have our own DB engine called Aurora, wherein the size of the compute can increase and decrease based on the actual number of transactions that are hitting a database. Very revolutionary model for a database, right? Even for compute, it is quite revolutionary, the way you can deploy your serverless architecture. Today we have many customers that are running in a completely serverless mode on AWS. When I say serverless, it's not that there is no underlying server, it's just that it is not managed by you, not even on cloud. So our compute service, Elastic Compute Cloud instance, or a VM, whatever you call it, you don't even have to manage that, right? Having said that, if you go above this layer, these are all PaaS services or managed services or serverless services, whatever you call them. Uh, any of these services, you don't have to manage the underlying infrastructure. And the beauty about managed services is that AWS takes care of the security, the AWS takes care of the high availability, as well as the scalability. And because of the way that you use these services, the cost also comes down drastically, right? So we have a plethora of services around analytics, full data lakes as a service available with multiple analytics option, application services available, DevOps services available, mobility related services available, IoT platform available, services around artificial intelligence and machine learning, enterprise applications including a virtual desktop VDI service called Workspaces, and all these you can run in a hybrid architecture. So we realize that a lot of enterprises will have their own data centers, and they'll not be able to shun everything and migrate in one shot. So we have created a hybrid architecture that you can continue for some time for some pieces of your applications and architecture on-prem, and utilize AWS like an extended arm of your data center. And then when you're coming for a tech refresh, you get to a stage of migration. So a lot of migration services available as well to ensure that the migration is smooth and easy for you without too much of downtime. So migration for server migration service to get your same image, database migration service to get your database up and running, application migration services. We have tools like Snowball, which can get your data lying on-prem in one shot. It has a capacity of 80 terabytes that you can order it and put it in your network, fill it up, and then send it back to AWS, and it can be moved into cloud. Also schema migration services, wherein you can change the schema of your database from one database into the other. And what we see is a lot of licensed database customers running licensed databases like Oracle and MS SQL Server. They are looking to move to managed open source databases. So we have Aurora as a DB engine, which comes in MySQL and Postgres flavors. In the last year and a half that we launched Aurora, we've seen almost 80,000 customers migrating onto Aurora. So the schema migration service can help there as well. Now, on top of all this, we have a marketplace where we have partners, product companies, which sell their software also in a pay-as-you-go model. So close to 4,000 plus softwares available, both licensed as well as open source. That you don't have to procure software through a different vendor. You can also procure those licensed products on the AWS marketplace. I'll probably pick up an example here. SAP HANA One database is available on AWS as an example at 99 cents per hour. Right, so you can try out. It can become a huge discovery platform, and then if you care to continue in a pay-as-you-go model, which usually makes more sense, you can do that. Or you choose to buy licenses separately after your discovery and work, that you can do that as well, right? And lastly is a team of AWS. So we have a fairly large team with different kind of people available. Pretty large team in India across 8 cities. People with handling accounts and solution architecture team, people with security specialization. There are training and certification teams available, a huge partner ecosystem that we have available, and then 24/7 support team that is available for you to support on any of your issues or concerns that you might have. Of course, support is also available as a subscription that you can subscribe to. So overall, as a platform, we today have 125 plus services. That's the speed at which we are adding the services. When I joined about 5 years ago, I used to sell the platform saying 30 plus services, and now we have reached to 125 plus services. That's all available and growing fast under all these categories. And that leads to the pace of innovation. So not only the number of services that are increasing, but also the features in these services that get added is also at a really fast pace. So these are a number of new significant features that have been added year on year. So you can see just 2017 alone, we added 1400 plus new significant features in just 1 year. So on an average, we are talking about 3 to 4 new features being launched. So AWS is running and innovating for you. And as a customer focused organization, Amazon, we say that we want to be Earth's most customer centric organization. So 90 to 95% of these updates that we launch are direct feedback from what our customers are asking us. So we follow a product feature request model. So if there is a service that you're using and you want an initial feature in that, you can make a request, and then based on the requests that we keep getting from our customers, we prioritize our releases, and then we put in our efforts to launch those features as fast as possible. And then that leads to security, right? So as so far you heard, the model is democratic model. All the services, features that are available to all our customers. So whatever features that you get, which are um, used by the largest of the enterprises, it's available to all of the companies. So one, you get a visibility into your entire infrastructure with a click, right? There is a cloud trail, which is an audit trail service. There are additional dashboards that are available that you can see your entire infrastructure in a matter of a few minutes. It's available all through your console. So there's no rogue IT model, the rogue IT server lying under someone's desk that happens here. Second, you have a very good control over it, who gets what kind of an access. You might want to give a developer only a developer access with some compute resources, wherein someone else you might want to give a admin access. So based on the roles, based on certain period of time, you can give access. And then auditability. So we go through multiple audit certifications, almost 50 plus audit certifications, regularly. And all those reports, SOC 1, SOC 2, SOC 3, PCI DSS level 1, ISO 27001, 9001, HIPAA, GDPR compliance we've added. So all those certifications, the reports are available through your console. And there's a section called artifacts, wherein you can just download the report in a matter of a few clicks. If you have gone through an audit of your data center, you can imagine the amount of effort and time and energy it takes. But on AWS, that job is reduced for you. You just with a few clicks download the report and attach that in your audit that you're doing, and your job is done. Right. We also call security as a shared responsibility on AWS. So when you're running in a data center, security is 100% your responsibility. However, when you run on cloud, the security of the cloud, which is operating system and below, is 100% our responsibility. But above the operating system, because AWS is a self-service model, whatever you run on a given VM is something only you can control. So security of that VM OS and above is still your part of the responsibility. What we do is we add a lot of features to ensure that it's very easy for you on the application security. There are a lot of features that are available, a lot of products that are available that you might be used to through our marketplace as well, that you can utilize just as you were utilizing in your data center. This is a quote from CTO of NASA. So based on our experience, I believe that we can be even more secure in AWS cloud than in our own data centers, right? So when NASA asks us for an additional features, it's not that we launch those additional features only for NASA. We will maybe, yes, we can take them as a beta customer to try out those features, but when we launch it in GA, it's available for all the customers, right? So that's the benefit of a platform which is democratic to all the customers. So the next reason why customers choose AWS is the expansive ecosystem of our partners. We have a lot of consulting partners. As you can see, we have local partners in India, which can help you in your cloud journey. We have partners in most of the cities, all 8 cities that we have teams. We have partners as well. So local partners can come in and work with you in getting started with your journey. As I mentioned, AWS is a self-service platform. AWS team can help you, consult you, and give you an advice on solution architecture. But when it comes to doing things, you either do things yourself or you utilize a partner who can fasten up your journey on cloud. AWS Marketplace, as I was telling, 3,800 plus softwares available across 1,100 sellers with one-click deployment for the software as well, along with the IT infrastructure that is required to run that software. Again, I'll take an example of analytics. Now, if you're a large enterprise, you might have different people within your group who might be looking at different products for analytics. And let's say some people use MicroStrategy, other people might say I need Informatica, Jaspersoft, Teradata, ClickView. We have our own service, QuickSight. Anything that you need is all available on the AWS Marketplace. So different teams can get satisfied with different products that you might want to use. At the same time, if you're looking to use a particular product, this is a great discovery platform, because before you buy the licenses, you can try it out, even the software, in a pay-as-you-go model. And after you've chosen the product, you can take a call whether you want to go the license way or you want to continue in a pay-as-you-go model. Typically, pay-as-you-go works well because then the hardware also with the one-click deployment can be utilized on the AWS platform. All right. AWS is positioned as a leader in the Gartner Quadrant. Last 6 years, we've been pushing the Gartner Quadrant towards the right, and it has been, rated as the highest in the ability to execute as well as in the completeness of vision. And in terms of the market share, they say that the market share for AWS is multiple times that of all the rest of the providers put together. So when we launched AWS for startups, it really helped because they had so many ideas and they wanted to get started without any upfront investment. And you can see startups globally, the likes of Airbnb, Netflix, and Tinder, and uh, all of the startups that started early 2000. Some of them you can't even call them as startups. They've become large enterprises now. In India also, if you see, as per the Your Story report, 90 plus startups of the top 100 run on AWS, and I don't have to go take you through the logos. You can see self-explanatory. But as we see these startups, coming onto the platform, what they are doing is they are disrupting businesses, and they're creating new ways to serve customers. So enterprises are also not, standing behind, getting disrupted. They are also, becoming agile with, cloud adoption. Again, you can see customers across verticals like Tata Motors, HDFC Life, is using for data lake. Bajaj Finserv is running the lending platform. Jubilant Foods running their SAP S/4HANA. NDTV is running their platform, news platform. Hotstar is running their sports portal, the entire Hotstar portal on AWS. Across verticals, you can see customers in media, healthcare, manufacturing, IT, ITS, PFSI, are using AWS Cloud. So let's go to overview of AWS services. We covered the basics of cloud computing. We covered why customers use AWS, and now let's look at some of the AWS services, to get started. So compute, we'll start with, and as I was telling earlier, EC2 Elastic Cloud Compute is our VM. It's available with Windows as well as Linux, multiple flavors of Linux, be it SUSE, Ubuntu, Red Hat, as well as Amazon Linux that is available. Pay as you go model with a hourly based pricing, but a per second based billing, right? So the price published is, let's say, 20 cents per hour. But if you stop an instance, a Linux instance in 20 seconds, you pay only for those 20 seconds. A beautiful feature on cloud is auto scaling with AC2. So, auto scaling lets you add additional capacity based on the actual traffic that might be coming in, right? So a lot of workloads have a spike in that traffic. It could be a daily spike. It could be a weekend spike. It could be a festival spike. So at that point of time when the actual traffic comes, additional capacity gets deployed, and when the peak goes, the additional capacity is given back to AWS. Right. Again, this helps you designing your sizing your infrastructure based on the base load rather than your peak load, and that helps in reducing your software that you buy on a per core basis as well. Third, we have a service called Elastic Load Balancer. As I was explaining our multi-AZ model, Elastic Load Balancer can expand traffic and can divide traffic across EC2, across availability zones. So you can use ELB for your web server layer or your app server layer, and then divide traffic across availability zones, and you can use auto scaling so that it scales out horizontally. As your traffic increases, it can add more infrastructure, and when the traffic subsides, it can reduce it back. Storage services, EBS, Elastic Block Store, it is nothing but network attached storage, which you can mount it on EC2 instance and run your VM. You have S3, which is simple storage service, which is the object store. You can put in all your data that you have available in images, videos, files, backups, snapshots. It's a object store that is accessible via the internet via API. From S3, we have multiple versions of S3, but I'll not go into those details for today's session. But a variant of S3 is Glacier, which is a cold storage, which is useful for archiving and backup purposes. So in S3, you can retrieve data immediately. In Glacier, it takes it's a cold storage, 2 to 3 hours time to retrieve your data. But both of them have 11 nines of durability that we give. 99.9999999% of the time you will not lose your data. So solid durability, and then the charges are pay as you go. So it's a bottomless bucket, as you can see here. Without you don't have to provision any amount of storage here. Based on the amount of data that you have, you put it in this and you pay 2.5 cents per GB per month for S3, half cent per GB per month for Glacier. I was talking about our price reductions that we keep doing, price drops. 67 price drops that we have done from the beginning, from 2006 till now. When I joined AWS 5 years ago, the cost of S3 was 9 cents per GB per month. That is dropped down to 2.5 cents per GB per month. So about 70% price drop in my tenure. Of course, it must have seen price drops before I joined as well. And then we have a service called Storage Gateway, which can integrate your applications on-prem with AWS Cloud, wherein it can take backups on a continuous basis onto S3 or Glacier. The Storage Gateway helps you connect between your applications running in your on-prem data center into cloud on S3 or Glacier. Third comes networking and CDN services. So as I was telling you, on AWS, which is a public cloud, you first thing you set up is a VPC, which is your virtual private cloud. This is an isolated section of the AWS cloud for you. Just like you design your data center, you create a range of IPs within which you'll be deploying your IT infrastructure. You create your public subnets, you create your private subnets. If it is your database instance, if it is your app server, you'll put it everything in private subnet. If it is your web server, you'll put it in your public subnet. By default, all these instances come with all security groups, all ports closed. You open the port that needs to be open. Let's say if it is a web server, you want to open port 80 or 443, you do that, but otherwise it comes with all ports closed. CloudFront, which is a CDN service, which helps you improve the experience for your customers, where you are deploying web services or websites, web applications. If you've deployed a particular application, let's say in India, you might see that your users, accessing that particular content from US might see a good amount of latency, right? But with CDN, as I was explaining you, we have 136 locations, edge locations across the world. So the content gets cached into these edge locations, and then it's served locally from the cached location to the end user across the world, right? So the first user, whenever they ask for a specific content, it goes to the hosted location, then it brings it back and caches it in the local edge server, and then it distributes the content from there. In India, we have 6 POPs, 2 in Mumbai, 2 in Delhi, 1 in Bangalore, and 2 in Chennai. So actually 7. We launched second POP in Delhi last week, which is the 136th POP that was launched last week. And then we have Route 53, which is our DNS service. We give 100% availability SLA for our DNS service Route 53, which again uses all these edge locations across the world. Moving on to database services, so you can run your database on an EC2 instance on a hardware as such, like you do it on an on-prem model. But we have managed DB services as well, wherein you don't have to worry about your minor OS level updates or DB level updates. We take care of backups every few minutes, every 5 minutes to be precise. And we have a multi-AZ model as well in RDS, wherein master and slave are deployed across availability zones. So master in one availability zone and slave in the other availability zone, with synchronous replication between master and slave. Now, synchronous replication is possible only if the latency is not beyond 10 milliseconds. And the beauty is, if the master goes down, slave takes over as the master without any downtime, without any loss of transaction, without any manual intervention from your side as well, right? And RDS is available in Oracle flavor, MS SQL, MySQL, Postgres, MariaDB, the other version of MySQL, and then we also have Aurora, which is our own DB engine with underlying engines of MySQL and Postgres. We also have license included models for Oracle and MS SQL Server. So if you don't want to, buy licenses, otherwise you can use it if you're using it for some test and dev purposes. You don't have to buy licenses. You can run the instances for a few hours, and you pay not only for your hardware but also for your software that you're using, license included in a pay-as-you-go model only for those many hours. Then we have DynamoDB, which is our NoSQL database service, similar to Mongo or Cassandra, you call it, but the beauty is it's a managed service. So you just tell us how many IOPS you need, how many read IOs, how many write IOs, and we manage the underlying shard, as many shards that are required. Again, you have services like auto scaling available in this. You have features like global table available in this, wherein it can synchronize those tables across regions, and you can serve the customers locally, depending upon whichever region you're serving those customers. Elastic Cache, which is an in-memory caching database service available in Redis as well as Memcached service. So if you're looking to use auto scaling, you also have to ensure that your application servers are running in a stateless model, because when the instances get rolled out, because the less traffic, your session data should not be on those servers. So you can utilize either a Elasticache or a DynamoDB in such situations as well. Moving on, deployment and administration services. So CloudWatch is a monitoring service that is available on AWS. It monitors the utilization and parameters for all AWS services that are deployed on your AWS console. Again, very important in the realm of cloud. I'm sure you use some monitoring services on-prem as well, but when you see a low utilization on-prem, what do you do? Nothing. You might see that the utilization is 20%, but you hardly can take any action basis that. But on AWS, this plays an important role. If you see an instance which is being used 20% utilization, all you do is right-click, modify to a smaller size instance, and restart. And from that hour onwards, you start paying less, right? So very, very useful to monitor your utilization, and helps you in your cost optimization. This also works very closely with your auto scaling and elastic load balancer, because that is where the parameters get picked in, based on the parameters that you want to have additional servers come in or go down, like a percentage CPU utilization, for example. So that metric is picked up from CloudWatch. IAM, which is Identity and Access Management, I already explained. Based on the users and groups, you can give permissions. You can integrate with your Active Directory as well, that you might be using. CloudFormation is a very important piece where I spoke about going global. This is basically creating a template of your entire architecture, and it's a JSON template. So that template you can then deploy in another region altogether in a matter of few minutes. If you're a product company and you're running a given architecture for a given customer in a given location, it's a very useful feature wherein you can deploy the entire architecture for a different customer, even if it is in the same region or in a different region. A lot of DevOps tools available for complete CI/CD pipeline that you can utilize on AWS, and your entire application lifecycle management can be maintained on AWS with all these DevOps services that are available. So how to get started? So first of all, you need to create your account on AWS. You have to go to aws.amazon.com and sign up with your credit card or debit card. And you need to validate your phone number as well as your payment instrument, which is either debit card or credit card. And the moment you have the account activated, you have a free tier available, that you can utilize. Most of the AWS services are available for trial purposes in the free tier. So have a look at the limits that are available. The free tier is valid for a period of 1 year, and it is available on all new accounts that you create. So most of the services you want to try out with a small size, which is available in free tier before you start working in a serious mode. So for example, the EC2 VM service for free tier, there is an instance type called T2 Micro, which comes with 1 GB RAM, 1 vCPU instance, and that is available for 750 hours in a month and up to 12 months. So you can run one Linux or a Windows VMT2 micro, one vCPU, 1 GB RAM for one whole straight full year, and you'll not be charged for it, right? But it's important to look at what is available in the free tier, and all the limits are available in the free tier. The moment you cross the free tier, the bill comes. Now you might cross the free tier if you're using these limits after 1 year, but if you go beyond some of these limits in a given month, your bill can get started in the first month itself, right? So here it says 750 hours of Linux available. So if let's say you run two instances and you run them for 400 hours each, that means you have run them for 800 hours. So 750 will go in the free tier, and then additional 50 will get billed, right? Similarly, if you're not using T2 micro, but you're using a larger instance, that instance is not part of free tier, so the bill for that will get started from the first hour, right? Similarly, S3, we have 5 GB storage available from the free tier database, again 750 hours, T2 micro in a single AZ model. If you use multi-AZ, you'll be paying for the entire multi-AZ RDS. CloudFront with 50 GB data transfer out. Similarly, all the services, most of the services that are there have a free tier, but just remember, it is not a free account. It is a free tier for you to learn, and anything that you start using beyond the free tier limits will get charged to you. So we use a post-paid model. When you validate your account with your payment instrument, there is a small 2 rupee charge which is just done to validate your credit card or debit card, but it is returned back to you. And we use a post-paid model. So whatever you consume throughout the month, basis the hourly rates, basis the per GB rate, various services, the bill comes on your third of next month on your credit card, based on your last month's consumption. Now, for customers which are running production workloads and are running a large amount of bill which cannot be paid through a credit card, we also have invoicing options. So you can raise a request through a ticket on AWS console, wherein our team looks at eligibility, and if you're eligible, your payment method can be updated to invoicing instead of credit card, wherein you start getting the invoice and then you have other facilities to pay through wire transfer or something like that, with a net 30 days terms or net 15 days terms basis your eligibility. All right, so the first thing once you've created your account is to get your IAM users created. So as I was mentioning, you can create your users in group, in bulk, and you can give them permission accordingly. You can control what resources they can use. You can control what time they use, what kind of access. All the fine-grained control is available to you. And then you can create your users and give them the access to using AWS. We also suggest that you create multi-factor authentication, especially for your root account. So you can use a hardware-based Gemalto tokens, or even soft authenticators like Google Authenticator. so that your root account is is secured. And you can enable this on IAM users as well as a root account, but definitely we strongly suggest that you do it for root account. Then EC2, as I was saying, these are virtual machines running on the cloud. You have full control of the instance. You can install any software that you choose. You can choose the instance type and size for various amounts of memory and CPU and hard disk combinations. You'll need a key pair and a security group to launch the instance to get into that. Within EC2, we have multiple families of instances. So when we started with a general purpose balanced CPU and RAM. So M stands for multipurpose. And as we started working, a lot of customers were using more compute, but RAM was utilized less. So they came back saying that you're wasting RAM, and because I'm using more compute, I'm being moved to the higher size, and which again leads to underutilized RAM. So we created a compute optimized instance family called C family, C for compute. Similarly, we also created a memory optimized family, R for RAM, where you get more RAM, less compute. In compute optimized, you get more compute, less RAM. We also have X1 instance, which is extreme RAM. So R5, it is available up to 244 GB RAM instance types. X1 starts with 512 GB RAM, 1 TB, 2 TB, 4 TB RAM, and even higher. These are especially meant for SAP HANA kind of workloads which require extreme memory that is available. So in Mumbai region, we have instances that are available up to 4 terabytes of RAM that you can utilize. We also have other instance types which are IO optimized, GPU based instance, storage based instance that are available, and also entry level test and dev instance, which are T2s that you can utilize for your test and dev workloads. Any production workloads, we suggest that you pick up from any of these. So for example, if you're running a database, you might want to run it on a R family because database requires more RAM. If you're running some compute workloads like HPC, you might use a C family. For your web servers, app servers, you might want to continue on M family. You can do a mix and match in your architecture. In terms of billing options, we have multiple billing options available on AWS. You start with on demand, which is you get started anytime and stop anytime, no questions asked. The moment you stop paying for it. If you're running your test dev workloads, very good use case to run on demand. During the day, you can start the server, and as you're going home, you can stop the server. Next day, come back and start it where you left. In a matter of few minutes, it starts as is. So you can save all the time that you didn't use, overnight, weekends, holidays, all the hours that you actually don't use your test and dev servers. You save all the money. Production instances which are running 24/7 after you've run on demand, you've done the right sizing. You have a discounted pricing model called reserved instance pricing model, wherein you can reserve an instance for a period of 1 year or 3 years. Again, multiple billing options available with no upfront investment, with partial upfront investment, full upfront investment, in standard as well as convertible modes. So based on your requirement and your cash flows, you can choose one of the discounted models under reserved instance. Now, whatever capacity that we have available extra beyond on demand and reserve, we make it available in a spot model, wherein you can bid for that extra capacity in a spot fashion. And use some of the heavy duty compute workloads like an HPC cluster or a big data EMR kind of workloads or a movie rendering kind of workloads, wherein you need huge amount of compute for a small period of time. you can use Spot, very, finely. Now, the other beauty is you can also mix and match these pricing models. So for your steady state, whatever bare minimum, you can run it in reserved model. Anything additional capacity, you can bring in on demand or on spot, and run in a optimized fashion on AWS. Some of the best practices: choose the relevant instance type, as I was mentioning, so that you don't even waste, additional capacity in even one instance. Stop the instances when you're not using. Backup the instance by creating an AMI backup. So whatever you're running in an instance, you can create an AMI, Amazon Machining Image, including your application as well. And next time you can take a backup, and next time you want to install the same application, your entire stack, you can run it in one single AMI. Just run that AMI, and you can get the instance up and running. Avoid stop and start within the hour is an old best practice. Now you can do that with per second billing option on Linux. And then lock down access using security groups. As I was telling, it comes with all ports closed. You open the port that needs to open, but ensure that you're opening only the right ports. On Amazon EBS, which is network attached storage, Elastic Block Store is a persistent block storage. There are a lot of EC2 instances which also comes with an ephemeral storage, but just remember that if you choose to run ephemeral storage, the moment you stop the instance, whatever is stored on ephemeral storage also goes away. So if you don't want that, then you need to use EBS, which is Elastic Block Store, which is persistent storage, and as small as 1 GB and goes as high as 16 terabytes. Available in several types, which I'll come and which I'll share in the next few slides. You can create snapshots of easy EBS volumes into S3 and create backups. So if you're not using a particular instance, the EBS volume, you can take a backup in S3. And then if you're coming back after a week or a month, you can always create a new EBS volume using that snapshot. Different types, as I was telling you, SSDs, general purpose SSD, you have provision IOPS that are available, which give you a sustained amount of IOPS guaranteed. You have throughput optimized HDD, and then cold HDDs as well. So based on your use case, you can use the type of storage that might suit you best. But what we are seeing of late is that the price difference between general purpose SSD and the others are, pretty less. So we always suggest get started with SSD as a best practice, and then if you need any specific, let's say a DB instance where you need specific amount of IOPS, you choose the provision IOPS. But I think it's a safe start for you to get started with general purpose SSD and get the good performance that it brings in at a pretty good cost. S3, as I was telling you, S3 is simple storage service, which is why S and 3. You can store and retrieve, almost any amount of data. One object, there is a limit of 5 terabytes, but we have customers running that, data in petabytes and some of them on exabytes as well. Highly scalable and durable. As I was telling you, 11 nines of durability available. You have encryption option available, so you can keep your data secured at rest, and of course in motion as well, using IPsec tunnel between AWS VPC and your on-prem. You can create a VPN over an IPsec tunnel. And then objects exist in the AWS region you choose, so the data residency gets served. Again, you can set up permissions and easily accessible. You can, if you want, you can make it make it available over the internet as well. A lot of people run their static websites just on AWS S3, Amazon S3, without even using a VM or a EC2 instance. But of course, if you don't want to give any access to anyone, you can keep that access private. RDS, as I was telling you, fully managed relational database service. These are the 6 flavors that are available: cost efficient and resizable capacity, managed backups and software patching, automatic file failure with multi-AZ model. In multi-AZ, if master fails, it creates the new slave in the other availability zone, with application diverting all the transactions to the existing slave, which has now become a master. So all that happens transparently without you having to do any manual intervention there. Billing and cost management. This is pretty interesting. These are the features which help you manage your cost effectively. You can monitor your costs and visualize your spend. You have Cost Explorer available through your billing section of your console. You can put alerts on the spending alert, spending on AWS. You get detailed reports. One of the best practice on alerts is that I give. If you're running in a free tier, just put a billing alert of $1 or $10, whatever is small enough for you. And the moment you cross the free tier and you're getting that bill, that means somewhere or the other you've crossed the free tier. And if it is done on purpose and you know about it, that's fine. But if you didn't know and that was done by mistake, you are getting an alert. That is something that you need to look in and take action. We also have a consolidated billing option available. So large enterprises, what they do is they run different groups under different accounts altogether, so that different cost centers are using different AWS accounts. But when it comes to billing, they consolidate using consolidated billing options available using a feature called organizations. And that way they're paying through only one bill, and they're also getting the benefits of the volume discounts that are available on AWS. If all groups put together, you're crossing certain volume discount tiers, you get those benefits as well. Support, which is 24/7, 365 available to you, but you need to subscribe for it. When you start an account, if you're just using it for free tier, you can be on basic support, which is under no SLA. But if you're running and starting and developing an application, we suggest that you move to dev support at that point of time, wherein you can create tickets over email and get support during the working hours, 8 to 5. But when you move to production, any workload, then we suggest you move to next level support, which is called business support, where you have support access 24/7, 365 over email, live chat, as well as phone. And they can help you in all the issues that you might have at any given point of time. So just remember, if you're running a production workload on AWS, we always recommend that you should be on business support. So if you're not, just go ahead and subscribe. There's a cost associated to it. Business support comes at 10% of your monthly bill, or $100, whichever is the whichever is the higher. So if you're billing anything less than $1,000, your business support cost will be $100. Anything more than that, it will be 10% of your monthly bill. This is where you can get details of our support: aws.amazon.com/premier support. We are almost at the fag end. So we covered the last part, which is the case studies. So this is a case study from Tata Motors. So Tata Motors at any given point of time is doing 30 to 40 POCs in parallel. So any ideas that come in, business comes with any ideas that they want to do. They don't say no to any POCs that they want to do. The cost of POC could be $200, $500, but they're able to run all those in parallel, and they are able to that then get to the successful ideas and innovation to their business much faster. So their vehicle tracker management application is running on AWS. They run multiple portals on AWS. The telematics vehicle, with sensor fitted on each vehicle, that application. Your learning portal is running on AWS. There are multiple other applications that have also they've deployed. Again, idea is it brings up and increases the innovation quotient. Future Group again, runs their e-commerce applications. They also run their SAP Hybris in a hybrid format. They were on-prem for their EC2, and they are running Hybris on AWS with the integration between on-prem and hybrid with some of our services like Direct Connect, which also gives point-to-point connectivity, and of course through VPN over IPsec tunnel. NDTV is a very interesting use case from a scale perspective. So they've been running on AWS from quite some time, and during national elections in 2014, they were trying to architect for the size, but obviously no one knew what kind of traffic on that day they will receive. So before election, on a given day, they used to get about 350 million hits, per day. And on the day of election, of course, they were rightly architected. They were able to scale to receive that kind of a traffic. On the day of election, they received 13 billion hits on May 16, 2014, right? They were able to scale and still give a great performance to the users. And after the election day is over, they're back to the lower traffic. The beauty is because they gave great experience to the users, they settle down almost 30 to 40% increased traffic. That's an increase in business because of a great experience on that one day. Some of the important links on AWS, we have architecture center for various use cases. You can look at some sample architectures that are available. aws.amazon.com/architecture. Entire documentation of AWS is available publicly. All the blogs if you want to follow. You have quick labs if you want to practice some of these instances, some of these services without creating your account. You have some of the free quick labs, and also there are some paid quick labs as well. Training and certification, you can go to this link and just do /certification. You can get to the certification page. We also have a partner by the name A Cloud Guru, wherein you can buy their subscription for certification training through either marketplace or directly from them as well. They have a nice mobile app as well with a lot of self-paced videos. They help you prepare for AWS certifications. There's a YouTube channel that you can subscribe to, and there is a SlideShare channel as well that you can subscribe to. Lot of content available publicly. Whatever you need, just Google for it, AWS and the keyword, and I'm sure it can take you to one of these places and many more that is available. This is the business development contact, that is contact-india@amazon.com. If you want to reach out and get your journey started on cloud, our team can assist you and can help you in assessing the price. Monthly pricing calculator is available publicly. They can help you in in your architecture, in sizing that might be required, in helping you understand what kind of monthly bill you'll be paying. If you're running on-prem and you want to see what is your TCO comparison on AWS, they can help you do that as well. So we call it still day one, which is the day one culture at Amazon, that we are still as excited, as customer obsessed as we were on our day one, and that's what keeps us going. I'd like to sum it up with the same business model that I explained earlier, that it's a no upfront model, no upfront investment that you have to get started with. There's no contract that binds you to stay on AWS, and then there's no commitment that we are asking you as well. So the only way we retain our customers is to ensure that the customers are satisfied and happy on the platform. We put them in happiness quotient in 4 buckets. One is we need to ensure that the customers are secured all the time. Second, we need to ensure that they're getting all the right support from all the team members as well as our support channel. Third, the technology innovation. So we keep innovating, we keep bringing in the new hardware on customers' behalf, with new processors on customers' behalf, so that you get the benefits of the pace of innovation that is happening at AWS. And fourth is that we keep dropping the prices as well, right? So that's our mantra to retain our customers. And with this mantra, we've become a $24 billion run rate business as of last quarter. Last quarter results for Q2 was $6.1 billion quarterly. So if you just to analyze the run rate, it comes to about $24 billion and growing at 49% year on year, which makes us the fastest growing multi-billion dollar company in the world. But yeah, it's still day one. We are as excited as we were on day one and happy to onboard you and get you started on your cloud journey. This is my email ID, balanic@amazon.com. If you need to reach out to me, I keep updating, with new features through social media on LinkedIn as well as Twitter. So if you care to join me in your network or follow me on Twitter, happy to add you and stay in touch. So with that, I'm done with my presentation. We still have about 10 more minutes that we can take questions. So with that, let me open my control panel and open the questions bar. So Rahul, I'll look at you as well. If there are any specific questions you want me to take it.
Sure, John.